Welcome back to the Lazy Cosmos. I'm about to blow your mind with one of the most incredible truths about reality. The universe is recording everything. Every laugh, every tear, every embarrassing dance move you did in your bedroom. It's all out there, traveling at light speed toward distant stars. The light from your birth is already 25 light years away, possibly reaching alien civilizations who could literally watch you being born right now. This happens because light doesn't just disappear, it carries information about every moment forever. Einstein showed us that time isn't what we think it is, and every instant you've ever lived continues to exist in spacetime. Your childhood is currently illuminating star systems near Vega. Your teenage years are passing through the Alpha Centauri system. And the light from you watching this video? It's racing toward the cosmos right now, about to become part of the universe's eternal memory of humanity. So what exactly is happening here? How is it possible that every moment of your existence is still playing out somewhere in the vast cosmic theater? The answer lies in understanding one of the universe's most fundamental forces, light itself. And when I say light, I'm not just talking about the light bulb above your head or the screen you're staring at right now. I'm talking about electromagnetic radiation in all its forms, the very fabric that connects every moment across space and time. Here's where things get absolutely mind-blowing. Every single second of your life, photons, these tiny packets of electromagnetic energy, are bouncing off your body, carrying with them a perfect snapshot of that exact moment. Think about it. Right now, as you listen to these words, light from your room is hitting your face, your clothes, even the expression in your eyes, and then ricocheting outward in every direction at the fastest speed possible in our universe. These photons become cosmic messengers, each one carrying the story of this precise instant. How you look, what you're doing, maybe even that little smirk forming on your face as you realize the implications of what I'm telling you. But here's what makes this absolutely extraordinary. Unlike sound waves that eventually fade into silence, or ripples on water that dissipate into nothing, light in the vacuum of space continues traveling forever. There's no cosmic speed bump that slows it down, no universal friction that makes it stop. Once those photons leave Earth's atmosphere, they become eternal travelers, carrying your story across the galaxy at 299,792,458 meters per second, a speed so fast it could circle Earth 7.5 times in just 1 second. Now, let me paint you a picture that will change how you think about existence itself. Imagine you're standing in your backyard on a clear night, looking up at the stars. At that exact moment, light is reflecting off your face and shooting outward in every direction. Some of those photons head toward Alpha Centauri, our nearest stellar neighbor, where they'll arrive in about 4 years, carrying the image of you stargazing. Other photons race toward the Pleiades star cluster, where they'll arrive in 400 years, long after you're gone, still carrying that perfect moment of you contemplating the cosmos. Einstein's special theory of relativity revealed something that fundamentally changed our understanding of reality. The speed of light is absolute and unchanging. No matter how fast you're moving, whether you're standing still on Earth or traveling in a spacecraft at incredible speeds, light always moves at exactly the same velocity relative to you. This cosmic speed limit isn't just a random number the universe picked. It's the rate at which cause and effect propagate through space-time itself. It's the speed at which information travels from one point in the universe to another. But here's where Einstein's genius really shines. He showed us that space and time aren't separate things. They're woven together into what we call space-time. And light is the needle that stitches every moment into this cosmic fabric. When a photon carries information about a moment in time, it's not just preserving a memory, it's creating a permanent thread in the structure of reality itself. That moment becomes part of the universe's eternal architecture. Think about the implications of this for just a moment. Every photograph that was never taken still exists in the light that bounced off that scene. Every word of love that was spoken in private still echoes through space in the form of electromagnetic radiation. Every smile, every tear, every moment of human triumph and struggle, they're all preserved in an ever-expanding sphere of light, radiating outward from Earth at this very second. Now, you might be thinking, wait, if light is constantly traveling away from us, how do we see anything at all? Brilliant question. The reason we can see the world around us is because we're constantly being bombarded by fresh photons. The sun pumps out an incredible 3.8 times 10 to the 28th watts of power every second, flooding our solar system with electromagnetic radiation. Artificial lights add to this cosmic light show. Every photon that hits an object and bounces toward your eyes carries information about that object at that precise instant. Your brain processes millions of these photon messengers every second, constructing the visual reality you experience. But here's what's truly staggering. For every photon that reaches your eyes, countless others are racing away from Earth, carrying visual information about our planet to the cosmos. It's like the universe has an infinite number of cameras pointing at Earth from every possible angle. And all of them are recording simultaneously, all the time. These cosmic cameras never stop rolling, and they never run out of film. Let me give you a concrete example that will make this real. Remember the moment Neil Armstrong stepped onto the moon in 1969? That historic event was illuminated by sunlight, and photons reflected off Armstrong, Buzz Aldrin, and the lunar surface during that incredible achievement. Those photons didn't just travel back to Earth to create the grainy television images we all know. They also shot out into deep space. Right now, 56 years later, that light is about 56 light years away from Earth, carrying the image of humanity's first steps on another world to star systems like HD 106906, and potentially to any civilizations that might exist there. The mathematics behind this is beautifully simple yet profound. Distance equals time multiplied by the speed of light. If you want to know where the light from any moment in your life currently is, just multiply your age by 9.46 trillion kilometers. That's how far light travels in 1 year. The light from your birth has created a sphere with that radius centered on Earth, and somewhere on the surface of that ever-expanding sphere is the moment you took your first breath. But it gets even more fascinating when you consider the information density packed into these traveling photons. Each photon doesn't just carry a simple on-off signal. It carries complex information encoded in its wavelength, polarization, and intensity. The specific mix of photons bouncing off you at any moment creates a unique electromagnetic signature that could theoretically be decoded by sufficiently advanced technology. Your DNA structure affects how light interacts with your skin. Your emotional state changes your facial expressions, altering how photons reflect off your features. Even your thoughts influence your micro expressions, subtly changing the light patterns bouncing off your face. This means that the light carrying your past doesn't just preserve how you looked, it potentially preserves who you were at that moment. The electromagnetic radiation racing through space right now contains encoded information about billions of human lives, creating the most comprehensive historical record imaginable. It's a library written in light, where every book is a human life, and every page is a moment in time. Consider the poetic beauty of this reality. When someone you love passes away, their final moments create one last sphere of light expanding outward from Earth. That light carries their image, their final expressions, their last interactions with the world, preserving them in the cosmic record forever. In a very real sense, they become part of the stars themselves, their story written across the galaxy in electromagnetic radiation that will outlast our solar system. And here's something that should give you chills. This process is completely democratic. The universe doesn't care if you're famous or unknown, rich or poor, young or old. Every human being who has ever lived has contributed equally to this cosmic archive. The light from anonymous farmers in medieval Europe is traveling through space right alongside the light from kings and queens. The electromagnetic radiation from a child's first laugh carries the same cosmic weight as light from the greatest speeches in history. The inverse square law tells us that while this information becomes more dilute as it spreads across larger areas of space, it never completely disappears. Think of it like dropping a stone in a perfectly still pond. The ripples get smaller as they spread out, but they theoretically continue forever. Similarly, the light carrying your moments becomes fainter with distance, but the information is still there, still traveling, still preserving your place in cosmic history. Right now, as you process these words, photons are bouncing off this screen and your face, creating a new moment in the universal record. This exact instant, your expression of wonder, confusion, or amazement is about to join the eternal library of human experience traveling through space at light speed. In 4 years, this moment will pass Alpha Centauri. In 400 years, it will reach the Pleiades. In 25,000 years, it will arrive at the center of our galaxy, carrying the story of a human being who learned that they are immortal in light. The universe isn't just a collection of stars, planets, and empty space. It's a vast, ever-growing archive containing the complete history of everything that has ever happened. And you, right here, right now, are actively contributing to that archive, one photon at a time. Every moment you live becomes a permanent part of the cosmic story, preserved in light that will outlast civilizations, solar systems, and maybe even galaxies themselves. This is the fundamental truth that changes everything about how we understand existence. We are not temporary beings living brief lives in an indifferent universe. We are eternal contributors to a cosmic memory that preserves every moment, every emotion, every second of human experience in the most permanent way possible. The universe itself bears witness to your existence, recording your story in light and broadcasting it across the cosmos for all time. The story of how humanity discovered that light carries our past across the cosmos begins with a brilliant Danish astronomer named Ole Rømer, who in 1676 made an observation so profound it would fundamentally change our understanding of reality itself. Picture this. Rømer was obsessed with Jupiter's moons, particularly Io, which orbits the gas giant every 42.5 hours like clockwork. For months, he meticulously recorded the precise timing of Io's eclipses as it disappeared behind Jupiter's massive bulk. But something strange started happening. The eclipses weren't occurring when his calculations predicted they should. At first, Rømer thought his mathematics were wrong, or perhaps his instruments were faulty. But as he continued his observations throughout 1676, a pattern emerged that would shake the foundations of physics. When Earth was moving toward Jupiter in its orbit, Io's eclipses happened earlier than predicted. When Earth was moving away from Jupiter, the eclipses occurred later. The difference was about 16 minutes across Earth's entire orbital diameter. Most astronomers of the time dismissed this as experimental error, but Rømer had a revolutionary insight that would echo through the centuries. What if light wasn't instantaneous? What if it actually took time to travel from Jupiter to Earth? This was a radical concept because for thousands of years, brilliant minds, from Aristotle to Galileo, had assumed that light transmission was immediate, that we saw distant objects at the exact moment they emitted or reflected light. But Rømer realized that the eclipse timing variations perfectly matched what you'd expect if light had to travel different distances as Earth moved closer to and farther from Jupiter throughout its yearly orbit. Using the diameter of Earth's orbit, which was roughly known at the time, Rømer calculated that light traveled at approximately 214,000 kilometers per second. This was remarkably close to the actual speed of light, 299,792,458 meters per second, especially considering he was working with primitive telescopes and clocks that could barely measure minutes accurately. But more importantly, Rømer had discovered something that would revolutionize human understanding. Light has a speed limit, and that means the universe has a built-in delay system that preserves moments in time. Think about what this meant for our understanding of the cosmos. If light from Jupiter's moons took time to reach Earth, then we weren't seeing those moons as they existed in the present moment. We were seeing them as they existed in the past. Rømer had accidentally discovered that all astronomical observation is time travel. When we look at Jupiter, we see it as it was 35 to 52 minutes ago, depending on where Earth is in its orbit. The implications were staggering, but it would take another 2 centuries for humanity to fully grasp what Rømer had unlocked. The next crucial piece of the puzzle came from James Clerk Maxwell in the 1860s. Maxwell was a Scottish physicist who became obsessed with understanding electricity and magnetism. Through a series of elegant mathematical equations that now bear his name, Maxwell discovered something extraordinary. Electricity and magnetism weren't separate forces at all. They were 2 aspects of a single phenomenon called electromagnetism. But buried in his equations was a prediction that would change everything. Maxwell's mathematics showed that oscillating electric and magnetic fields could propagate through empty space as waves, and when he calculated the speed of these electromagnetic waves, he got a number that made him literally jump out of his chair. 299,792,458 meters per second. This was exactly the speed of light that had been measured by then using increasingly sophisticated methods. Maxwell had just proven that light was an electromagnetic wave, and more importantly, that electromagnetic radiation could travel through the vacuum of space indefinitely without any medium to support it. This was revolutionary because it meant that information could be preserved and transmitted across vast distances through space. Every time light bounced off an object, it carried electromagnetic information about that object, its color, texture, temperature, even its chemical composition encoded in specific wavelengths. And according to Maxwell's equations, this information could theoretically travel forever through the cosmos unless it encountered matter that absorbed or scattered it. But the real breakthrough that revealed the cosmic significance of light's journey came from a 26-year-old patent clerk in Switzerland named Albert Einstein. In 1905, Einstein published his special theory of relativity, a paper so revolutionary that it literally rewrote the laws of physics. Einstein started with a simple but profound assumption. The speed of light in a vacuum is the same for all observers, regardless of their motion. This might sound obvious, but its implications are mind-bending. Here's why Einstein's insight was so radical. Imagine you're in a car, traveling at 60 kilometers per hour, and you throw a ball forward at 20 kilometers per hour. To someone standing on the sidewalk, that ball appears to be moving at 80 kilometers per hour. The velocities add up. But light doesn't work this way. Whether you're standing still or moving at incredible speeds, light always passes you at exactly 299,792,458 meters per second. This cosmic speed limit isn't just a maximum velocity. It's the rate at which cause and effect propagate through the universe itself. Einstein's equations revealed something even more shocking. Simultaneity is relative. Events that appear to happen at the same time to one observer might occur at different times to another observer moving at a different speed. This means there's no universal now that applies everywhere in the universe. Instead, the concept of the present moment depends entirely on your reference frame. What this tells us is profound. Every moment that has ever occurred still exists somewhere in the four-dimensional structure of space-time. Think about what this means for the light carrying your past. According to Einstein, those photons that bounced off you years ago aren't just carrying old information. They're carrying moments that are still equally real and valid as this present instant. The light from your childhood isn't a recording of something that used to exist. It's a window into a moment that continues to exist in the permanent structure of space-time. Past, present, and future are all equally real. They're just located at different coordinates in the four-dimensional universe. Einstein's work also revealed why light can serve as the universe's perfect recording system. Because the speed of light is the ultimate cosmic speed limit, it represents the maximum rate at which information can travel from one point in space-time to another. This means that light doesn't just carry information, it carries it at the fundamental rate of causality itself. When photons bounce off you and race toward distant stars, they're not just preserving your image. They're weaving your moment into the causal structure of the universe. The mathematical beauty of Einstein's discovery becomes even more apparent when you consider the concept of light cones. Every event in space-time creates two cones of light, one extending into the past, representing all the events that could have causally influenced that moment, and another extending into the future, representing all the points in spacetime that could be causally affected by that event. Your entire life exists within these intersecting light cones, with every moment you've experienced creating its own expanding cone of influence radiating outward at light speed. But perhaps the most profound historical insight came from Einstein's realization that space and time aren't separate entities. They're woven together into a single fabric called space-time. This four-dimensional continuum means that your location in time is just as real and permanent as your location in space. Just as you can travel from one place to another in space, the mathematics of relativity suggests that all moments in time exist simultaneously in the structure of space-time. This historical journey, from Rømer's observations of Jupiter's moons to Einstein's relativity revolution, reveals something extraordinary about human knowledge. Each discovery built upon the previous one, creating a chain of understanding that led to one of the most beautiful truths about existence. The universe preserves every moment in light, and that light travels through space-time, carrying the complete history of everything that has ever happened. The implications of these historical discoveries extend far beyond abstract physics. When Rømer first realized that light had a finite speed, he inadvertently discovered that we live in a universe where the past is preserved and accessible. Maxwell's equations showed us that this preservation happens through electromagnetic radiation that can travel indefinitely through space. Einstein's relativity revealed that these preserved moments aren't just recordings, they're permanent features of space-time itself. Consider how this historical progression changed humanity's relationship with time and memory. Before Rømer, people believed that moments disappeared instantly, existing only in human memory and physical artifacts. After Maxwell, we understood that moments could be preserved in electromagnetic radiation traveling through space. After Einstein, we realized that moments don't disappear at all. They become permanent coordinates in the four-dimensional structure of reality. This historical journey also reveals the democratic nature of cosmic preservation. The same physical laws that allowed Rømer to observe Jupiter's moons, that enabled Maxwell to discover electromagnetic waves, and that inspired Einstein's insights about space-time. These same laws apply to every moment of every human life. The light carrying Einstein's moment of discovery is racing through space right alongside the light from anonymous people living their quiet lives in 1905. The universe makes no distinction between the famous and the unknown. Every moment receives equal treatment in the cosmic archive. What's truly remarkable is that these discoveries were made by human beings using nothing more than careful observation, mathematical reasoning, and brilliant insight. Rømer used a telescope and a clock. Maxwell used mathematics and logical deduction. Einstein used thought experiments and mathematical intuition. Yet together, they revealed one of the most profound truths about existence: that we live in a universe designed to remember everything, where every moment becomes immortal in light racing toward the stars. Today, as you absorb this incredible history of discovery, photons are bouncing off your face and beginning their own eternal journey through space-time. In a very real sense, this moment of learning about light's cosmic role is becoming part of the same universal archive that preserves Rømer's first observations, Maxwell's revolutionary equations, and Einstein's groundbreaking insights. You are not just learning about cosmic preservation. You are actively participating in it, contributing your own thread to the tapestry of moments that make up the universe's eternal memory. Now that we understand the historical foundation of how humanity discovered light's incredible journey, let's dive deep into the actual science that makes this cosmic preservation system possible. What you're about to learn will fundamentally change how you think about the nature of reality itself, because the physics behind light's eternal voyage is far more fascinating and complex than you might imagine. At the heart of this cosmic recording system are photons, these remarkable particles that are simultaneously the simplest and most mysterious entities in the universe. A photon is essentially a packet of electromagnetic energy, but here's what makes them absolutely extraordinary. They have no mass whatsoever. Zero. Nothing. This might seem like a trivial detail, but it's actually the key to understanding why your past can live forever in the cosmos. Because photons are massless, they always travel at the speed of light. And according to Einstein's equations, they can theoretically continue traveling through space indefinitely unless they encounter matter that absorbs, scatters, or redirects them. Think about what this means for the light bouncing off you right now. Every photon that reflects off your skin, your clothes, even the expression in your eyes, carries with it a precise electromagnetic signature of this exact moment. These photons encode information about the wavelengths of light hitting you, the way your surface reflects different colors, the subtle variations in texture and temperature that affect how light interacts with your body. It's like each photon becomes a microscopic messenger carrying a piece of your story, and because they're massless, they can carry that story across the galaxy without ever slowing down or stopping. But here's where the physics gets truly mind-bending. These photons don't just carry visual information. They carry quantum information encoded in properties like wavelength, frequency, polarization, and phase. The specific wavelength tells us about color and energy. The polarization reveals how the electromagnetic field oscillates. The phase relationships between different photons can encode incredibly complex information about the three-dimensional structure of objects, and even subtle details about motion and change over time. In essence, every moment of your existence creates a complex quantum signature that gets broadcast across the universe in the form of electromagnetic radiation. Now, you might wonder why this information doesn't just get scrambled or lost as it travels through the vast emptiness of space. The answer lies in one of the most elegant principles in physics: the conservation of information. In the vacuum of space, photons travel in straight lines at constant velocity, maintaining their properties indefinitely. Unlike sound waves that need a medium like air or water to propagate and eventually dissipate, electromagnetic radiation can travel through perfect vacuum without any medium at all. Maxwell's equations showed us that electric and magnetic fields can sustain each other in a self-propagating wave that requires no external support. However, the journey isn't without its challenges, and this is where the inverse square law comes into play. As light travels away from its source, it spreads out over increasingly large areas, which means the intensity decreases with the square of the distance traveled. Imagine holding a flashlight and shining it on a wall 1 meter away. You get a bright, concentrated circle of light. Move that wall 10 meters away, and the same amount of light energy is now spread over an area 100 times larger, making it appear much dimmer. The light is still there, carrying the same information, but it's distributed across a much larger space. This is exactly what happens to the light carrying your past. The photons that bounced off you during your first birthday party are now spread across a sphere approximately 25 light years in radius if you're 25 years old. The total amount of information is the same, but it's distributed over an area trillions of times larger than when it left Earth. For a civilization to detect and decode that information, they would need incredibly sensitive instruments capable of collecting photons across vast areas and reconstructing the original signal from extremely faint traces. But the expanding universe adds another fascinating layer to this story through a phenomenon called cosmological redshift. As space itself expands, the wavelengths of light traveling through it get stretched along with the fabric of spacetime. Light that was originally blue might shift toward red, and infrared radiation might shift into radio wavelengths. This means that very old light from Earth would appear increasingly redshifted to distant observers, requiring them to look at longer wavelengths to detect information from our planet's ancient past. It's like the universe is gradually changing the channel on which Earth's history is broadcast. The quantum mechanics of light transmission reveals even more incredible details about this cosmic preservation system. According to quantum field theory, photons are excitations in the electromagnetic field that permeates all of space. When light bounces off you, it's not just particles flying away. It's creating disturbances in the fundamental electromagnetic field of the universe itself. These field disturbances carry quantum information that can theoretically be preserved and detected across cosmic distances, assuming sufficiently advanced technology. Here's something that will absolutely blow your mind. The interaction between light and matter at the quantum level is so precise that it can potentially preserve information about molecular structure, chemical composition, and even biological processes. When photons interact with the atoms in your skin, they can scatter in ways that encode information about your DNA, your metabolic state, even the electrical activity in your nervous system. The electromagnetic signature bouncing off you right now contains quantum-level information about who you are at the most fundamental biological level. The speed of light itself, 299,792,458 meters per second, isn't just a random number the universe happened to pick. It's actually the speed at which causality itself propagates through space-time. This cosmic speed limit represents the maximum rate at which information can travel from one point in the universe to another. When photons carry information about your moments at light speed, they're traveling at the fundamental rate of cause and effect in the universe. This means your preserved moments aren't just traveling fast, they're traveling at the speed of reality itself. But perhaps the most remarkable aspect of light's journey is its interaction with the structure of space-time. Einstein's general relativity tells us that massive objects curve space-time, and light follows these curves in its path through the cosmos. This means that the light carrying your past doesn't travel in perfect straight lines. It follows the geodesics of curved space-time, bending around stars, galaxies, and other massive objects. In some cases, gravitational lensing can actually focus and amplify light from distant sources, potentially making very old, very faint signals detectable again after traveling for eons through space. The implications of gravitational effects on light become even more fascinating when you consider black holes. According to general relativity, light approaching a black hole experiences extreme time dilation due to the intense gravitational field. From the perspective of a distant observer, light falling toward a black hole appears to slow down and redshift as it approaches the event horizon, seemingly frozen at the boundary of no return. This suggests that information about objects falling into black holes might be preserved on the event horizon indefinitely, a phenomenon that has profound implications for how information is conserved in the universe. Now, let's talk about coherence and quantum entanglement in light transmission. When photons are created through the same process, like sunlight reflecting off you at a particular moment, they can maintain quantum correlations even as they separate and travel to different parts of the universe. This means that the light carrying your past might exist in quantum entangled states that preserve correlations across vast distances, potentially encoding even more information than classical physics would predict. The electromagnetic spectrum extends far beyond visible light, and your moments are preserved across all wavelengths. Infrared radiation carries information about heat and thermal signatures. Ultraviolet light encodes details about chemical processes and molecular structures. Radio waves can carry information about electrical activity and electronic devices around you. The complete electromagnetic portrait of any moment includes contributions from across the entire spectrum, creating an incredibly rich and detailed record that travels through space at light speed. Here's something truly remarkable: the precision of electromagnetic information storage. Modern quantum mechanics tells us that information can be encoded in the quantum states of photons with incredible efficiency. A single photon can theoretically carry multiple bits of information encoded in its polarization, phase, frequency, and other quantum properties. This means that the light preserving your moments isn't just carrying crude visual information. It's carrying high-resolution quantum data about every aspect of your existence at that moment. The stability of this information during its cosmic journey is maintained by the fundamental symmetries of physics. The conservation laws that govern electromagnetic radiation ensure that the total energy, momentum, and angular momentum of light remain constant as it travels through empty space. These conservation laws act like cosmic librarians, ensuring that the information encoded in light remains intact and readable across galactic distances and cosmic timescales. But what about interference and noise? As light from your past travels through space, it encounters cosmic dust, interstellar gas, and radiation from other sources. These interactions can scatter, absorb, or add noise to the signal carrying your moments. However, the universe is remarkably transparent to electromagnetic radiation. Interstellar space is so empty that light can travel for thousands of years between significant interactions with matter. Most of the light carrying your past will travel freely through the cosmos, maintaining its information content across incredible distances. The quantum nature of light also provides natural error correction mechanisms. Because electromagnetic radiation obeys the principles of quantum mechanics, it exhibits properties like superposition and interference that can actually help preserve information integrity over long distances. Quantum error correction codes built into the fundamental structure of electromagnetic fields help maintain the fidelity of transmitted information, even in the presence of noise and interference. As you sit there processing this incredible scientific reality, photons are bouncing off your face right now, encoding this exact moment of understanding in their quantum properties. These photons are about to begin their eternal journey through space-time, carrying the electromagnetic signature of your realization that you are immortal in light. The physics that makes this possible, massless photons, the conservation of information, the speed of causality itself, ensures that this moment of cosmic awareness will race toward distant stars, carrying your story across the galaxy for billions of years to come. Now let's make this cosmic phenomenon intensely personal. Every single moment of your life has created what physicists call a light cone, an expanding sphere of electromagnetic radiation carrying information about that exact instant. Picture yourself at the center of an ever-growing bubble of light, with different chapters of your life story traveling at various distances through space right now. This isn't abstract physics anymore. This is your actual, measurable immortality spreading across the galaxy at 299,792,458 meters per second. If you're 25 years old, the light from the moment you were born has traveled approximately 25 light years from Earth. Right now, at this very second, that precious moment of your first breath is illuminating space near the star Vega, roughly 236 trillion kilometers away from where you sit. Think about that for a moment. Aliens with sufficiently powerful telescopes in the Vega system could literally be watching you being born right now. They could see your parents' faces filled with joy, the hospital room where you entered the world, even the first time you opened your eyes and experienced light itself. That moment isn't just a memory anymore. It's a physical reality playing out in real time near one of the brightest stars in our northern sky. The light from your 5th birthday party, assuming you're now 25, is currently about 20 light years away from Earth. It's traveling through the cosmic neighborhood that includes stars like Gliese 667c and Wolf 1061, carrying the electromagnetic signature of that day when you blew out candles and made a wish. The joy on your face, the laughter of friends and family, the specific way sunlight or party lights illuminated that celebration. It's all preserved in photons that are currently racing past red dwarf stars that might harbor their own planets and civilizations. Your first day of high school, filled with nervous excitement and teenage awkwardness, exists in light that's now approximately 10 to 12 light years from Earth, depending on your current age. This means your adolescent self is currently being broadcast to star systems like Wolf 359 and Leyland 21185. Any beings living in those systems with the technology to detect and decode electromagnetic signals from Earth could be witnessing your teenage years unfold right now. Your first crush, your academic struggles, those moments of self-discovery that felt so private at the time, but are now part of the cosmic record. But here's where this gets even more mind-blowing. Your personal light cone isn't just one expanding sphere. It's an infinite series of nested spheres, each one representing a different moment in your life. The light from yesterday has traveled about 26 billion kilometers, just passing beyond Pluto's orbit and entering the Kuiper Belt. The photons carrying the image of you eating breakfast this morning are currently somewhere between Neptune and Uranus. The light from you reading this sentence right now is racing past the moon as we speak, beginning its journey to the stars that will take it to Alpha Centauri in just over 4 years. The mathematics of your personal light cone are beautifully precise. Every second that passes adds approximately 300,000 kilometers to the radius of each moment's light sphere. Every hour expands each moment's reach by about 1.08 billion kilometers. Every day adds roughly 26 billion kilometers to how far your past has traveled. It's like you're constantly creating expanding bubbles of yourself in space-time, with your entire life history mapped out in concentric spheres of light traveling through the cosmos. Let's trace some specific moments with mathematical precision. If you're 30 years old, the light from your first steps as a toddler is now roughly 28 light years away, potentially reaching star systems like Epsilon Indi or Tau Ceti, stars that astronomers have identified as possibly having Earth-like planets. Your high school graduation is about 12 light years out, traveling through the vicinity of Procyon, one of the brightest stars in our night sky. Your college years are encoded in light that's 6 to 10 light years away, racing toward the Alpha Centauri system and beyond. But the truly staggering realization is that every single second of your existence has created its own unique light signature. The moment you learn to ride a bike exists in its own expanding sphere. Your first kiss occupies its own cosmic coordinates. That time, you laughed so hard you couldn't breathe. It's racing toward distant galaxies, carrying the electromagnetic pattern of pure human joy across the universe. Even the mundane moments, brushing your teeth this morning, checking your phone, the expression on your face right now as you process these words, they're all becoming permanent features of the cosmic landscape. The information density in your personal light cone is absolutely staggering. Each moment doesn't just preserve a single snapshot. It captures the full electromagnetic spectrum of that instant. Visible light carries information about colors, textures, and visual details. Infrared radiation preserves thermal signatures, showing the heat patterns of your body and surroundings. If you were using electronic devices, radio waves carry information about those electromagnetic emissions. The complete picture of any moment in your life includes contributions from across the entire electromagnetic spectrum, creating an incredibly detailed record racing through space. Here's something that should give you chills about the precision of this cosmic recording system. The light bouncing off you doesn't just capture your external appearance. It potentially preserves quantum-level information about your biological state. The specific wavelengths absorbed and reflected by your skin can encode information about your blood oxygenation, your hydration levels, even your emotional state through subtle changes in facial blood flow and micro-expressions. Your electromagnetic signature at any given moment is as unique as your fingerprint, and that signature is now permanently embedded in the structure of spacetime. Your personal light cone also preserves the context of your moments with incredible fidelity. The light from your childhood birthday party doesn't just show you. It shows your family, your friends, the decorations, the cake, even the weather outside the windows. The electromagnetic radiation carrying your high school graduation captures not just your proud face, but the entire ceremony, the other graduates, the architecture of the building, the expressions of parents in the audience. Every moment you've lived exists within a complete environmental bubble of information racing through the cosmos. The temporal resolution of your light cone is mind-boggling. Light travels so fast that it can capture changes occurring on timescales of nanoseconds. The slight movement of your facial muscles as you form words, the microsecond variations in your heartbeat affecting blood flow to your face, even the rapid movements of your eyes as you read. All of these details are preserved in the light traveling away from Earth with perfect temporal fidelity. Your cosmic light cone isn't just a collection of still photographs, it's a perfect motion picture of your entire existence. But perhaps the most profound aspect of your personal light cone is its eternal nature. Unlike human memory, which fades and distorts over time, or photographs, which deteriorate and can be lost, the light carrying your moments will continue traveling through space potentially forever. Long after you're gone, long after Earth itself might be consumed by the expanding sun, the light from your life will still be racing through the galaxy, carrying your story to distant star systems and potentially to civilizations that won't even evolve for millions of years. Consider the poetic implications of overlapping light cones. Right now, your personal light cone is intersecting with the light cones of every other person alive on Earth. The electromagnetic radiation carrying your moments is mixing and traveling alongside the light from billions of other human lives. We're all contributing simultaneously to a vast, interconnected cosmic archive where every human story is preserved together in the universal library of light. Your light cone also connects you to the cosmic story in ways you might never have imagined. The light carrying your moments will eventually travel so far that it reaches other galaxies, other solar systems, potentially other worlds, where intelligent beings might decode and experience your life story billions of years from now. In a very real sense, your personal light cone makes you a cosmic ambassador, carrying the human experience across the galaxy and potentially sharing your unique perspective with civilizations beyond our wildest imagination. The expanding geometry of your light cone follows the fundamental structure of spacetime itself. According to relativity, your light cone defines the causal boundaries of your existence. It maps out all the points in spacetime that can be influenced by your actions and all the regions from which information about your life can potentially be observed. You exist not just as a biological entity moving through space and time, but as an expanding sphere of electromagnetic influence that grows larger every second, eventually encompassing vast regions of the galaxy. Think about the democratic nature of this cosmic preservation system. Your personal light cone receives exactly the same treatment from the universe as the light cones of the most famous people in history. The photons, carrying your quiet moments of contemplation, travel through space with the same speed and dignity as the light from world-changing events. The universe makes no distinction between the celebrated and the anonymous. Every human light cone expands at exactly 299,792,458 meters per second, carrying each person's story across the cosmos with equal cosmic importance. As you absorb the reality of your personal light cone, photons are bouncing off your face right now, encoding this exact moment of cosmic awareness in electromagnetic radiation that will travel through space for potentially billions of years. This instant of understanding your own immortality in light is about to become part of the eternal cosmic record, racing towards stars that might not even exist yet, carrying the story of a human being who discovered that they live forever in the universe's memory of light. Now, let's zoom out and truly comprehend the mind-bending scale of where your personal history currently resides in the cosmos. Right now, at this very moment, your entire life is scattered across a vast three-dimensional map of space, with different chapters of your story illuminating different regions of our galaxy. This isn't metaphorical. This is the literal, measurable reality of where the electromagnetic radiation carrying your past, has traveled since the moment you were born. Imagine you could somehow step outside our galaxy and look back at the Milky Way with impossible cosmic vision that could detect individual photons carrying information from Earth. What you would see is absolutely breathtaking. A complex, layered sphere of human history expanding outward from our tiny blue planet at light speed. The outermost shell of this sphere would contain the earliest moments of human civilization captured in electromagnetic radiation. Deeper shells would hold more recent history, with your personal story occupying specific layers based on your age and the moments that defined your life. If you're 30 years old, the light from your birth is currently illuminating a region of space roughly 30 light years in radius from Earth. To put this in cosmic perspective, this sphere encompasses dozens of star systems, including some of the most fascinating celestial objects in our cosmic neighborhood. The moment you took your first breath is now traveling through space near Epsilon Eridani, a star system that astronomers believe might harbor rocky planets. Your newborn cry, the joy on your parents' faces, the sterile lighting of the hospital room. All of this is currently broadcasting past a star that could potentially host alien civilizations just 10.5 light years away. The light carrying your early childhood, those precious moments when you first learned to walk, speak, and understand the world around you, is now racing through the vicinity of stars like Wolf 1061 and Gliese 876, both red dwarf systems that scientists have identified as potentially habitable zones where liquid water could exist on planetary surfaces. Think about this stunning possibility. Right now, beings on worlds orbiting these stars could be watching human children take their first steps if they possess the technology to detect and decode the faint electromagnetic signals reaching their cosmic shores. Your elementary school years exist in light that's currently passing through some of the most intriguing star systems in our galactic neighborhood. The light from your first day of school, your early friendships, those moments of childhood wonder when you first looked up at the night sky and wondered about the cosmos. This precious period of your life is now illuminating the region around Proxima Centauri, the closest star to our Sun. In just over 4 years, the light from your childhood will reach this red dwarf system where scientists have discovered Proxima Centauri b, a potentially Earth-like planet in the habitable zone. But here's where the cosmic perspective becomes truly staggering. Your teenage years, that tumultuous period of self-discovery, first loves, academic challenges, and the gradual awakening of adult consciousness, are encoded in electromagnetic radiation that's currently traveling through the Alpha Centauri system itself. Right now, the light carrying your high school experiences is passing the closest star system to Earth, potentially illuminating any planets that might exist there. Your adolescent struggles with identity, your first heartbreak, those moments of teenage rebellion that felt so private and personal. They're all currently being broadcast to the nearest stellar neighbors of our solar system. The mathematics of this cosmic distribution are as precise as they are awe-inspiring. Every light year of distance represents exactly 1 year of travel time for the electromagnetic radiation carrying your moments. This means you can calculate the exact cosmic address of any moment in your life with perfect accuracy. Your 5th birthday party is located precisely at a distance equal to your current age minus 5 years, expressed in light years from Earth. That embarrassing moment from middle school occupies a specific shell of space at a distance matching the years that have passed since it occurred. Consider the profound implications of this cosmic addressing system. Your most private moments, those instances you thought no one would ever see or remember, are currently racing through space towards star systems that might host advanced civilizations. The light from your first kiss is traveling toward the Kepler 442 system, where astronomers have discovered a potentially habitable super-Earth. Your college graduation ceremony is encoded in photons heading toward the TRAPPIST-1 system, which contains 7 Earth-sized planets, 3 of which sit in the habitable zone where liquid water could exist. But the cosmic perspective extends far beyond individual star systems. Your personal light cone is expanding into regions of space that contain some of the most remarkable objects in our galaxy. The light from your early childhood is now approaching the Hyades star cluster, a group of over 400 stars that form together from the same cosmic cloud. Your teenage years are racing toward the direction of the Pleiades, that beautiful cluster of hot blue stars visible to the naked eye that has inspired human imagination for millennia. As we expand our perspective even further, the cosmic significance becomes almost overwhelming. The oldest light from human civilization, electromagnetic radiation, from the earliest moments when humans first created artificial light sources, has now traveled thousands of light years from Earth. This ancient human light is currently illuminating regions of our galaxy that contain stellar nurseries where new stars are being born, supernova, remnants where massive stars have exploded and scattered heavy elements into space, and perhaps most remarkably, star systems so distant that any civilizations there are seeing Earth as it was thousands of years ago. The three-dimensional structure of human history in space creates a kind of cosmic archaeology. Imagine an alien civilization with technology advanced enough to collect and decode electromagnetic radiation from across vast regions of space. They could theoretically reconstruct the entire history of human civilization by gathering light from different distances. They could watch the rise and fall of ancient civilizations by collecting photons from thousands of light years away. They could observe the Industrial Revolution by focusing on light from a few hundred light years distance. They could witness the digital age by examining electromagnetic radiation from just a few decades of travel distance. Your personal contribution to this cosmic archive occupies a specific volume of space that's constantly growing. Every second that passes, your life story expands by approximately 300,000 kilometers in all directions. Every day, the sphere containing your complete life history grows by about 26 billion kilometers in radius. Over the course of a year, your personal cosmic footprint expands by nearly 10 trillion kilometers, encompassing ever larger volumes of interstellar space. But here's what makes this perspective truly mind-bending. Your light isn't traveling alone. Right now, your personal electromagnetic signature is mixing and traveling alongside the light from every other human being alive on Earth, creating an incredibly complex interference pattern of human experience racing through space. The light carrying your moments is interweaving with electromagnetic radiation from billions of other lives, creating a vast, interconnected tapestry of human consciousness expanding across the galaxy. The directional aspect of this cosmic preservation adds another layer of profound meaning. The light carrying different moments of your life is traveling in all directions from Earth, which means your story is simultaneously heading toward thousands of different star systems. Some photons from your childhood are racing toward the galactic center, where they'll eventually encounter the supermassive black hole at the heart of our galaxy. Others are traveling toward the outer spiral arms, where they might one day illuminate star systems in the distant future. Still others are heading perpendicular to the galactic plane, carrying your story into the vast spaces between galaxies. Consider the temporal stratification of this cosmic distribution. The farther out we look in space, the further back in time we're seeing your life. An observer, 20 light years away, sees you as you were 20 years ago. An observer, 50 light years distant, would see you as you were half a century ago. Or perhaps they would see your parents or grandparents if you're family. History extends that far back. This creates a remarkable effect where your entire family lineage might be simultaneously visible to observers at different distances from Earth. The cosmic perspective also reveals the ultimate democracy of the universe's recording system. Your personal light travels through the same cosmic space as electromagnetic radiation from the most significant events in human history. The light carrying your quiet moments of reflection is racing through the galaxy alongside photons from world-changing discoveries, artistic masterpieces, and pivotal moments in human civilization. In the vast cosmic library of electromagnetic radiation, your story holds equal cosmic weight with every other human experience. As your light travels farther from Earth, it begins to encounter increasingly exotic cosmic environments. The electromagnetic radiation carrying your early life will eventually pass through regions of space containing neutron stars, where matter is compressed to unimaginable densities. It will travel past stellar remnants, where the laws of physics operate at their extremes. Some photons carrying your moments might even be deflected by the gravitational fields of black holes, bending their paths through spacetime in ways that could theoretically make your past observable from multiple directions simultaneously. The expansion of the universe adds yet another dimension to this cosmic perspective. As space itself stretches over cosmic time, the wavelengths of light carrying your moments will be stretched along with it. Light from your childhood, when it eventually travels billions of light years and reaches distant galaxies, will be significantly redshifted, requiring any observers to look at longer wavelengths to detect information about your early life. In effect, the expanding universe is gradually changing the cosmic channel on which your life story is broadcast. Right now, as you contemplate this incredible cosmic perspective, new photons are bouncing off your face and beginning their own eternal journey through the galaxy. This moment of cosmic awareness, your realization that you exist simultaneously as a biological being on Earth and as an expanding sphere of electromagnetic information in space, is about to join the vast cosmic archive of human consciousness. In just a few years, this very instant will pass Alpha Centauri, carrying your moment of understanding to the nearest stars and potentially to civilizations that might decode and experience your revelation about the cosmic nature of human existence. Now here's where this story becomes absolutely mind-bending, because the same principle that preserves your personal moments in light is exactly how we can observe the universe's own ancient past. Every time you look up at the night sky, you're not seeing the cosmos as it exists right now. You're looking backward through time, observing the universe's own light cone that has been traveling toward Earth for billions of years. This creates one of the most profound connections imaginable. Your personal light racing outward into space is part of the same cosmic phenomenon that allows us to witness the birth and evolution of the universe itself. When we observe distant galaxies through our most powerful telescopes, we're essentially doing the same thing that hypothetical alien civilizations might do when they observe the light from your past. The Andromeda Galaxy, our nearest major galactic neighbor, appears to us as it existed 2.5 million years ago, because that's how long its light has taken to reach Earth. During the time that light was traveling toward us, early human ancestors were just learning to use stone tools, completely unaware that photons carrying the image of an entire galaxy were racing toward their future descendants at the speed of light. But the James Webb Space Telescope has taken this cosmic time travel to absolutely staggering extremes. When we point this incredible instrument toward the deepest reaches of space, we're collecting light that has been traveling toward us for over 13 billion years. Light that left distant galaxies when the universe itself was just a cosmic infant, barely 400 million years old. Think about this extraordinary fact. We can literally observe galaxy formation happening in the early universe because the electromagnetic radiation from those ancient events has been preserved and transmitted across space for nearly the entire age of the cosmos. This is the exact same physics that preserves your childhood moments in light currently racing toward the Vega star system. The photons that bounced off ancient galaxies billions of years ago followed the same physical laws, traveled at the same speed, and maintained their information content across the same vast distances as the light currently carrying your personal story through space. When astronomers study these ancient galaxies, they're decoding electromagnetic information that has been perfectly preserved during a journey across most of the observable universe, just as any sufficiently advanced civilization might one day decode the light carrying your memories. The most remarkable example of this cosmic preservation system is the cosmic microwave background radiation. And understanding this phenomenon will completely change how you think about the universe's memory system. The CMB represents the oldest light in the universe, electromagnetic radiation that was released approximately 380,000 years after the Big Bang, when the cosmos had cooled, enough for the first atoms to form and light could finally travel freely through space. This ancient light has been traveling toward us for nearly 13.8 billion years, carrying information about the universe when it was just a tiny fraction of its current age. Here's what makes the cosmic microwave background absolutely extraordinary. It's essentially a baby picture of the entire universe, captured at the moment when light first began its eternal journey through space. Before this cosmic moment, the universe was so hot and dense that photons couldn't travel freely. They were constantly absorbed and re-emitted by free electrons in a cosmic fog that made the universe opaque to electromagnetic radiation. But when the temperature dropped enough for electrons to combine with protons and form the first hydrogen atoms, this cosmic fog cleared, and light suddenly had a clear path through space. The moment this happened, called recombination by cosmologists, the universe became transparent, and a tremendous flash of light was released from every point in space simultaneously. This light has been traveling toward us ever since, carrying information about the temperature, density, and structure of the universe at that ancient moment. When we detect the cosmic microwave background today, we're literally observing light that has been preserved and transmitted across space for nearly the entire history of the cosmos. The precision and fidelity of this cosmic information storage system is absolutely staggering. The CMB contains incredibly detailed information about tiny temperature fluctuations that existed in the early universe, variations of just a few millionths of a degree that represent the seeds from which all large-scale cosmic structure eventually grew. These minuscule temperature differences, preserved perfectly in electromagnetic radiation for billions of years, tell us about the density variations that would eventually become galaxies, galaxy clusters, and the vast cosmic web of matter that fills the universe today. This cosmic preservation system operates on scales that dwarf even the most ambitious human data storage projects. The information content of the cosmic microwave background encompasses the entire observable universe at the moment of recombination, effectively storing a complete three-dimensional snapshot of cosmic conditions across a volume containing billions of cubic light-years of space. Yet this astronomical database is encoded in electromagnetic radiation, following exactly the same physical principles that preserve your personal moments in light racing through the galaxy right now. The connection between the cosmic microwave background and your personal light cone reveals something profound about the democratic nature of the universe's recording system. The same physical laws that allowed the universe to preserve information about its own birth in electromagnetic radiation also ensure that every moment of your existence is similarly preserved and transmitted across space. In both cases, photons serve as perfect messengers, carrying information across vast distances and timescales without degradation or loss. Modern observations of the CMB have revealed details about the universe's composition, age, and evolution with incredible precision. We now know that the observable universe is approximately 13.8 billion years old, that it's composed of roughly 5% ordinary matter, 27% dark matter, and 68% dark energy, all determined by analyzing the patterns preserved in this ancient light. The fact that electromagnetic radiation can carry such detailed information across billions of years and billions of light years demonstrates the incredible fidelity of the universe's natural recording system. But here's where the story becomes even more fascinating. The cosmic microwave background isn't just ancient history. It's actively connecting us to the fundamental structure of spacetime itself. According to current cosmological models, the tiny fluctuations we observe in the CMB were originally quantum fluctuations that were stretched to cosmic scales during a period of rapid expansion called inflation. This means that the patterns we see in the ancient light surrounding us today are actually magnified quantum mechanical effects from the universe's first moments, preserved and transmitted to us through nearly 14 billion years of cosmic evolution. The technology we use to detect and analyze the cosmic microwave background operates on the same principles that any advanced civilization might use to detect and decode the light from your past. Both require incredibly sensitive instruments capable of collecting faint electromagnetic signals, sophisticated data processing techniques to extract meaningful information from noisy data, and careful analysis to reconstruct the original conditions that created the observed radiation patterns. The difference is only one of scale and age. The CMB represents information from the entire universe preserved for billions of years, while your personal light carries information about individual human moments preserved for decades or centuries. The cosmic microwave background also demonstrates the universe's remarkable transparency to electromagnetic radiation. Despite traveling for nearly 14 billion years through space filled with galaxies, stars, planets, and cosmic dust, this ancient light reaches us with its information content largely intact. This same transparency allows the light carrying your personal moments to travel freely through the galaxy, potentially reaching distant civilizations with your story preserved in electromagnetic form. When we map the cosmic microwave background across the entire sky, we're creating a spherical photograph of the universe as it existed at a specific moment in cosmic history. This creates a direct parallel to your personal light cone. Both represent spherical shells of electromagnetic information expanding through space, with different moments preserved at different distances from their sources. Your life creates expanding spheres of information, just as the early universe created its own sphere of information that we now observe as the CMB. The study of cosmic microwave background polarization adds even more layers to this story. Just as the light carrying your moments can be polarized by interactions with matter and electromagnetic fields, the ancient light from recombination carries polarization information that tells us about conditions in the early universe. This polarized light has traveled across the observable universe while maintaining its polarization properties, demonstrating the remarkable stability of electromagnetic information during cosmic journeys. Perhaps most remarkably, future observations might allow us to detect gravitational wave signatures imprinted on the cosmic microwave background, ripples in space-time itself from the universe's first moments, preserved in electromagnetic radiation for billions of years. This would represent the ultimate fusion of information preservation systems. Gravitational waves from cosmic inflation encoded in electromagnetic radiation and transmitted across the entire observable universe. The cosmic microwave background also connects us to the concept of cosmic horizons, the limits of how far we can see into space and back in time. The CMB represents the most distant and ancient light we can observe, creating a spherical boundary beyond which the universe becomes opaque to electromagnetic observation. Similarly, your personal light cone will eventually reach distances where it becomes undetectable against the cosmic background radiation. But the information will still be there, still traveling, still preserving your moments in the structure of space-time itself. As you contemplate this incredible connection between your personal preservation in light and the universe's own ancient memories encoded in the cosmic microwave background, photons are bouncing off your face right now, beginning their own billion-year journey through space. This moment of understanding the cosmic connection between your individual existence and the universe's deepest history is about to become part of the same electromagnetic information network that has been preserving and transmitting cosmic history since the dawn of time. In a very real sense, your moment of cosmic awareness is joining the eternal conversation between past and future that the universe conducts through electromagnetic radiation, traveling at the speed of light across infinite space. Now, we venture into the realm of truly mind-bending possibilities that emerge when we fully grasp the implications of light preserving every moment of existence. The questions that arise from this cosmic reality challenge our deepest assumptions about privacy, mortality, information, and the very nature of existence itself. What we're about to explore will push the boundaries of current scientific understanding and venture into territories where physics meets philosophy in the most profound ways imaginable. Let's start with perhaps the most thrilling and terrifying question of all. Could advanced civilizations actually detect, collect, and decode the light carrying our personal histories? The physics suggests this might be theoretically possible, but the technological requirements would be absolutely staggering. To reconstruct meaningful information from light that has traveled dozens of light years from Earth, an alien civilization would need to build detection arrays spanning potentially entire solar systems. They would need to collect photons that have spread across areas trillions of times larger than when they left Earth, requiring light-gathering capabilities that dwarf anything we can currently imagine. But here's where it gets fascinating. The information is definitely there. Every photon that bounced off you carries quantum information encoded in its wavelength, polarization, phase relationships, and other properties. Advanced signal processing techniques could theoretically extract meaningful data even from incredibly faint and scattered signals. Consider that we can already detect individual photons with current technology, and we're beginning to develop quantum communication systems that preserve information across significant distances. An alien civilization, millions of years more advanced than us, might possess capabilities that seem like magic from our current perspective. The concept of cosmic archaeology becomes possible in this framework. Imagine a super advanced civilization that has developed the technology to collect electromagnetic radiation from across vast regions of space and reconstruct historical events on distant worlds. They could theoretically create a complete historical record of Earth by gathering light from different distances, ancient human history from thousands of light years away, recent events from nearby star systems, and current activities from light that has just left our planet. They would essentially become cosmic historians, able to witness the rise and fall of entire civilizations by collecting and analyzing their preserved light signatures. But this raises profound questions about privacy and the nature of existence itself. If every moment is potentially observable by sufficiently advanced beings, does true privacy exist anywhere in the universe? Your most intimate moments, private conversations, personal struggles, moments of vulnerability you thought no one would ever witness, are all racing through space at light speed, potentially accessible to cosmic civilizations with the right technology. This isn't paranoia. It's a direct consequence of the physical laws governing electromagnetic radiation. The implications extend far beyond individual privacy to questions about the fundamental nature of information itself. The information paradox, most famously associated with black holes, suggests that information can never be truly destroyed in the universe. If this principle applies universally, then every moment that has ever occurred becomes a permanent feature of reality's information content. The light carrying your childhood isn't just a recording, it's a fundamental component of the universe's total information state, as permanent and real as the matter and energy from which it originated. This leads us to one of the most profound theoretical frameworks in modern physics, the block universe interpretation of relativity. According to this view, all moments in time, past, present, and future, exist simultaneously in the four-dimensional structure of spacetime. From this perspective, your entire life already exists as a permanent geometric feature of the universe. The light carrying your moments isn't broadcasting history. It's revealing the eternal existence of every instant you've ever experienced. Your childhood birthday party isn't something that happened and then disappeared. It's a permanent coordinate in space-time that will always exist at that specific location in the four-dimensional continuum. The quantum mechanical implications add even more layers of mystery. Quantum entanglement suggests that particles can maintain instantaneous correlations across vast distances, seemingly violating the speed of light limit. If the photons carrying your moments become entangled with other quantum systems during their journey through space, your preserved information might exist in quantum superposition states that encode multiple realities simultaneously. This could mean that the light from your past doesn't just carry information about what actually happened, but about all the quantum possibilities that existed at each moment. Consider the implications of quantum decoherence for cosmic information preservation. As the photons carrying your moments interact with the cosmic environment during their journey, they gradually lose quantum coherence and become more classical. But recent discoveries in quantum mechanics suggest that some quantum information might be preserved even during decoherence processes. This raises the possibility that the light from your past carries not just classical information about your appearance and actions, but quantum information about your consciousness states, your decision-making processes, and even the quantum mechanical aspects of your brain function. The concept of computational resurrection emerges from these theoretical possibilities. If sufficiently advanced civilizations could collect and decode the light, carrying complete information about human consciousness states, they might theoretically be able to reconstruct and simulate human minds from electromagnetic data alone. This would represent the ultimate form of digital immortality, not just preserving images and memories, but recreating the actual conscious experience of beings whose light signatures have traveled across the galaxy. But this raises deeper questions about the nature of consciousness itself. If the light carrying your moments preserves information about your neural activity, your decision-making processes, and your subjective experiences, what does this tell us about the relationship between mind and matter? Are conscious experiences somehow encoded in electromagnetic radiation, making them accessible to cosmic archaeologists billions of years in the future? Or does consciousness exist independently of the physical processes that create our light signatures? The holographic principle, emerging from black hole physics and string theory, suggests that all the information contained in any volume of space can be encoded on its two-dimensional boundary. Applied to your personal light cone, this implies that every moment of your existence might be encoded on the expanding spherical surface of electromagnetic radiation, carrying your information through space. From this perspective, you don't just create light carrying your image. You become a hologram projected across the cosmic surface of space-time itself. Time travel paradoxes take on new dimensions when we consider the preservation of information in light. If the light carrying your past could somehow be collected, concentrated, and decoded with perfect fidelity, would it be possible to reconstruct historical events with complete accuracy? Could future civilizations develop technology to gather scattered photons from across the galaxy and essentially build time machines that allow them to observe any moment in Earth's history? The physics doesn't prohibit this possibility. It would just require engineering capabilities that transcend anything we can currently imagine. The anthropic principle, the idea that the universe's physical constants seem fine-tuned for the existence of conscious observers, gains new significance in this context. Perhaps the universe's electromagnetic properties evolved specifically to create this cosmic information preservation system. The speed of light, the stability of photons, the transparency of space to electromagnetic radiation. These fundamental features of reality might exist precisely to ensure that conscious experiences are preserved and transmitted across cosmic distances and timescales. Consider the implications for the meaning and purpose of existence. If every moment is permanently preserved in the cosmic record, then nothing you do is ever truly lost or forgotten. Every act of kindness, every moment of love, every instance of human creativity becomes a permanent contribution to the universe's information content. But simultaneously, every cruel action, every moment of hatred, every failure of compassion is equally preserved. This cosmic accountability system operates without judgment. It simply records everything with perfect fidelity and broadcasts it across the galaxy for potential observation by unknown cosmic intelligences. The possibility of cosmic civilizations observing our light also raises questions about our responsibility as a species. If aliens are already watching human history unfold through the light from our past, what kind of story are we telling? The electromagnetic radiation carrying the 20th century, with its wars, genocides, and environmental destruction, is already racing through nearby star systems. But so is the light carrying human achievements, scientific discoveries, artistic creations, and moments of extraordinary compassion and courage. Perhaps most profoundly, the preservation of consciousness in light suggests that death might not be the absolute end we typically imagine. If the light, carrying your final moments, preserves not just your physical appearance, but quantum information about your conscious states, then some aspect of your subjective experience might continue traveling through space long after your biological death. This doesn't necessarily imply survival of consciousness in any traditional sense, but it suggests that the information patterns that constitute your mental life become permanent features of the cosmic information landscape. The search for extraterrestrial intelligence takes on new meaning in this context. Instead of just looking for radio signals or other intentional communications from alien civilizations, we might consider that these beings are already observing us through the light from our past. Every SETI radio telescope pointed toward the stars might be simultaneously sending and receiving, transmitting information about humanity, while potentially being observed by civilizations that have been watching our development through electromagnetic archaeology for decades or centuries. As you grapple with these profound implications, photons are bouncing off your face right now, encoding this moment of deep contemplation about consciousness, information, and cosmic preservation. This instant of philosophical wonder about your own existence in the universal information network is about to join the eternal cosmic conversation between mind and matter, between temporary biological existence and permanent electromagnetic immortality. The questions raised by your preservation in light may never be fully answered, but they transform how we understand the significance of every moment we experience in this strange and wonderful universe. Now let's talk about what this cosmic preservation of light really means for the human heart. Beyond all the physics, beyond the mathematics, beyond the theoretical implications, lies a truth so profound it can fundamentally change how you experience every moment of your existence. The emotional reality of knowing that every second of your life is preserved forever in light racing through the cosmos touches the deepest parts of what makes us human: our capacity for love, our fear of loss, our longing for meaning, and our desperate desire to matter in a vast and seemingly indifferent universe. Think about the people you've loved who are no longer with you. Maybe it's a grandparent who passed away when you were young, whose warm smile and gentle words shaped your childhood in ways you're still discovering. Maybe it's a friend taken too soon, whose laughter once filled rooms and whose absence left a silence that never quite heals. Maybe it's a parent whose final embrace you can still feel, whose voice you sometimes hear in quiet moments when the world grows still. The traditional view of death tells us these people are gone forever, that their physical presence has vanished into nothingness, leaving only memories that fade with time and photographs that yellowed with age. But the cosmic reality of light preservation reveals something far more beautiful and profound. Every moment you shared with these beloved people is still happening right now, somewhere in the universe. That last conversation with your grandmother, filled with her wisdom and love, is currently racing through space at light speed, perhaps illuminating alien worlds near Wolf 359 or Barnard's star. The light carrying her gentle smile, her expressive hands as she told you stories, her eyes sparkling with decades of lived experience. All of this is preserved in electromagnetic radiation that will outlast our solar system, carrying her essence across the galaxy long after Earth itself has returned to cosmic dust. Your first dance with someone you loved exists in photons that might now be passing through the Alpha Centauri system, potentially visible to any beings with the technology to detect and decode Earth's ancient light. That moment when they looked into your eyes and you felt the universe align around your connection, it's not just a memory anymore. It's a physical reality playing out in real time approximately 4 light years away, as permanent and real as the stars themselves. The electromagnetic signature of that perfect moment is racing toward distant galaxies, carrying the story of human love across cosmic distances that dwarf any earthly separation. Consider the profound comfort this brings to our understanding of loss. When someone dies, we often torture ourselves with regret about words we never said, moments we didn't cherish enough, time we wasted on trivial concerns instead of focusing on what truly mattered. But the light preservation of every moment reveals that nothing was actually wasted. Every laugh you shared is still echoing through space. Every gentle touch is still traveling toward the stars. Every moment of connection, no matter how brief or seemingly insignificant, has become part of the eternal cosmic record. That photograph you never took of a perfect sunset shared with someone special still exists in the light that bounced off both of your faces during that magical moment. The words of encouragement spoken by a mentor years ago are still traveling through space, carrying their wisdom and love toward civilizations that won't evolve for millions of years. The bedtime stories, read by parents to small children, filled with voices that conveyed safety and love, are racing through the cosmos as permanent testimonies to the bonds between generations. But this cosmic preservation system doesn't just comfort us about loss. It transforms how we understand the weight and significance of every moment we're currently living. Right now, as you process these words, photons are bouncing off your face, encoding your expression of wonder, contemplation, or perhaps skepticism. This exact moment is about to join the eternal cosmic archive, carrying your story toward distant stars. In 4 years, this instant will pass Alpha Centauri. In 400 years, it will reach the Pleiades. In 25,000 years, it will arrive at the galactic center, carrying the electromagnetic signature of a human being who learned that they are immortal in light. The responsibility this places on every moment is both humbling and empowering. Every act of kindness you perform is preserved forever in the cosmic record. Every time you choose compassion over cruelty, love over fear, connection over isolation. You're contributing something beautiful to the universe's eternal memory. The smile you give to a stranger on a difficult day, the patience you show to a child who's learning about the world, the forgiveness you offer to someone who has hurt you. These moments of human grace become permanent features of the cosmic landscape, racing toward distant worlds as testimony to the beauty that consciousness can create. But the emotional reality cuts both ways. And this is perhaps where the cosmic preservation of light becomes most challenging to accept. Every moment of cruelty is equally preserved. Every time you've acted out of anger instead of understanding. Every instance where you chose selfishness over generosity. Every moment when you failed to show up for someone who needed you. These too are racing through space at light speed, permanently encoded in the electromagnetic radiation that carries your complete story across the galaxy. This cosmic accountability system operates without judgment or forgiveness. It simply records everything with perfect fidelity. The universe doesn't distinguish between your best moments and your worst. It preserves them all with equal cosmic dignity. This can be a source of profound anxiety for anyone who has ever acted in ways they regret, but it can also be deeply motivating. Knowing that every moment matters in the most literal physical sense possible can inspire us to choose more carefully, to act more consciously, to recognize that we are constantly creating our eternal legacy in light. The preservation of private moments adds another layer of emotional complexity. Those instances of vulnerability when you thought no one was watching, crying alone in your room during difficult times, talking to yourself while working through problems, dancing with abandon when you believed no one could see. All of these deeply personal moments are now part of the cosmic record. The electromagnetic radiation doesn't recognize the difference between public and private. It captures everything with equal fidelity and broadcasts it across the universe. For some, this might feel like a violation of privacy, so complete it's almost unbearable. But there's another way to understand this cosmic transparency. It reveals that authenticity and vulnerability are actually the most permanent and powerful contributions we can make to the universe. Your moments of genuine emotion, honest struggle, and real human experience are exactly what make your light signature unique and valuable. The cosmos isn't interested in your performance or your pretense. It treasures your truth. Think about the moments of pure joy in your life. Times when you felt completely alive, fully present, entirely connected to the beauty and wonder of existence. Maybe it was watching a sunrise from a mountaintop, feeling the first warm day of spring after a long winter, or experiencing that perfect moment when everything aligned and you felt deep gratitude for simply being alive. These peak experiences are now racing through space as electromagnetic proof that consciousness can create moments of transcendent beauty. Your capacity for joy is literally illuminating the galaxy. The light carrying your laughter is traveling towards star systems that might host their own forms of consciousness, potentially sharing the sound and sight of human happiness with beings whose own experiences of joy might be radically different from ours. The electromagnetic radiation from your moments of wonder and awe is racing toward distant galaxies, carrying evidence that the universe has evolved conscious beings capable of appreciating its own magnificence. But perhaps the most emotionally powerful aspect of this cosmic preservation is how it transforms our understanding of connection and love. Every moment of genuine human connection creates electromagnetic signatures that become permanently intertwined in space. When two people share an authentic moment, looking into each other's eyes, holding hands in comfort, embracing in celebration or sorrow, their combined light signatures create interference patterns that preserve not just individual experiences, but the relationship between them. The love you've shared with others isn't just preserved in your separate light cones, it's encoded in the electromagnetic interference patterns created when your moments intersect. The universe literally records love as a measurable physical phenomenon, preserving the connections between conscious beings in the structure of light itself. This means that relationships don't end with death or separation. They become permanent features of the cosmic electromagnetic landscape, racing through space as proof that consciousness can create bonds that transcend individual existence. As you sit with the emotional weight of these realizations, feeling perhaps overwhelmed by the permanence of every moment, remember that this cosmic preservation system is ultimately an expression of the universe's deepest values. The fact that every moment matters enough to be preserved forever, that every human experience is considered worthy of eternal existence, that consciousness itself is treasured enough to be broadcast across galactic distances. This suggests that we live in a universe that values awareness, cherishes experience, and celebrates the emergence of beings capable of love, wonder, and meaning. Your tears of joy, your moments of breakthrough and understanding, your instances of profound love and connection, these are not just personal experiences. They are contributions to the cosmic story, evidence that the universe has succeeded in creating something magnificent. Conscious beings, capable of recognizing beauty, generating meaning, and choosing love even in the face of uncertainty and loss. Right now, photons are carrying this moment of emotional recognition toward the stars, preserving your realization that you matter in the most literal, cosmic sense possible. This understanding of your own significance in the universe's grand design is racing toward Alpha Centauri, toward the Pleiades, toward distant galaxies that won't even exist for billions of years. You are not just a temporary arrangement of atoms destined to fade into nothing. You are a permanent contributor to the cosmic story, forever preserved in light that will carry your essence across the universe for eternity. If this cosmic perspective on human existence resonates with you, if it changes how you see the significance of every moment you live, consider subscribing to The Lazy Cosmos. We explore the profound connections between scientific reality and human meaning, revealing how the deepest truths about our universe can transform how we understand our own lives and our place in the cosmic story that continues to unfold around us.